Hello again, class, and welcome to lesson 6.1.3. The objective today is to investigate the ambiguous case of the law of sines. Let's start by recalling the law of sines. The law of sines says that given a triangle, the sine of angle A over its opposite side A has to equal the sine of angle B over its opposite side B, which has to equal the sine of angle C over its opposite side C. Now, this is for triangles A, B, C, where side A is opposite angle A, side B is opposite angle B, and side C is opposite side C. Law of cosines. C squared has to equal A squared plus B squared, so it's kind of part of your Pythagorean theorem, minus 2 times A times B times the cosine of the angle opposite this side. Your law of cosines is used to help find missing sides and angles of non-right triangles when you're given side, 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 or you're given side, angle, side. Your law of cosine or law of sines is used when you have an angle, angle, side, or an angle, side, angle. Now, if you think about it, well, what's missing here is, what about a side-side angle? Description in a triangle. That's what we're going to try to investigate today, because it does lead to a very unique situation, which we call the case of the ambiguous case of law of sines. We're going to skip this snowball problem for now. If we need another example, we will come back to it. So if you end up watching this screen, you should skip it for now, because what we did is we went through the lesson and then we came back to do part A because we needed another example. Same thing with 642. If you see me writing anything here, skip it, because you do not need to watch it right now. But when we get done with the rest of the slides, we came back to this. Let's talk a little bit about solving equations that have sine in them. So if we were to find the measure of angle A in this diagram right here, we know that the sine of A is equal to 1/2. And we have that drawn in quadrant 1. If you solve the sine of A equaling 1/2, A ends up being equal to the inverse sine of 1/2, which means angle A comes out to be 30 degrees. But we're not done, because in your study of the unit circle, we know that there is another angle on the unit circle where the sine of 1/2, or the sine of angle A, equals 1/2. We need to find that other A, that other angle. We know that that has to occur in quadrant 2 because the sign is positive. +1 and a +2 for the radius of this circle. So the sine of A really has two solutions. It has the 30 degrees in quadrant 1 and then 150 degrees in quadrant 2 by taking 180 minus 30. So there are two solutions to this equation, sine of A equaling 1/2. This idea of there being two solutions because of quadrant 1 and quadrant 2 leads to an ambiguous case for certain triangles. And that's what we're going to look at next. Now, if we were actually hosting classroom sessions, we would have a hands-on activity where you'd be taking linguini and making triangles with it. If you want to do some of that at home, that's great. Feel free to take these slides and print them off in paper and grab some glue or tape and some straight pasta, and you can kind of do these activities. But we're going to just talk about them through this video. So there's not a whole lot on this page, but let's take this next one. We're going to take a look at what happens if we have this side-side angle situation occurring, where here's one side and here's my angle. Angle A is set at, approximately 50 degrees. Side B is a specific length. So here's my A, here's this S, and we want to create a triangle that doesn't really exist. We want to break off a piece of linguini so that side A, side opposite angle A, has a certain length that no triangle is created. Well, if I was to sketch that in here, that might look something like this. Here's length A. It's not long enough to reach this other side. If I was to extend this out, this isn't quite long enough to reach there. So what is the relationship of A to both H and to B? Well, in this situation, H represents the distance from the end of B down to the base, and A doesn't reach the base. Therefore, no triangle is created. Let's write this down. No triangle when A is less than H, when it's smaller than H. But now you want to take and break off a piece of linguini to represent A so that only one triangle can be created. So again, we have this side-side angle relationship. My A is right here. One of the sides, that's B. This is angle A. And this is going to be little a. And little a needs to create one triangle. That's going to be one triangle. Call that A. There isn't any other triangle that we could create if A is equal to the distance from the end of B to the base of our triangle. So if A equals H, one right triangle is created. Now here's where things get interesting. We want to find an A so that two triangles are created. So again, we got this side angle situation that we're exploring. This is angle A. This is side B. And we need to create A. Go with a different color here. Let's go red. So that two triangles where A is the same length are created. There's this A and there's this A. Or better yet, let's go two colors here. We've got that A or that A. They're the same, but it's going to create two different triangles. One of these triangles is going to have an acute angle, and that's going to be in green. This angle here is going to be acute, so I'm going to draw that over here. Looks something like this. Here's angle A, here's side B, and here's side A, meaning that this has to be angle B here, angle C, and side C. In the other triangle, this is going to be an obtuse angle. So I'm going to go down here and draw this, a little more room. This is still angle A. This is side B. Here's side A. And this angle B is now going to be more than 90 degrees. Little c, angle C. So in our triangles, here's what we're creating. In the green triangle, angle B, the measure of angle B, is going to be less than 90 degrees. And in the red triangle, that measure of angle B is going to be greater than 90 degrees. They're actually going to be supplementary to each other. In other words, if you add up these two angle B's, you'll get a total of 180 degrees. Additionally, we know that A has to be less than side B. So side A has to be less than side B, but it has to be greater than H, where H is that distance from the end of B to the base. This is a critical component for us to create the ambiguous case. What it's really saying is that this A value has to be smaller, this side here has to be smaller than this side. And sometimes you'll see it written as a little s, a big S, and then your angle. You want to create this scenario in order to have an ambiguous case, or if this scenario here is created, you'll have the ambiguous case. So let's take this ambiguous case and see what it looks like when we actually create a triangle given some measurements, some parameters. I'm going to pause this and draw the triangle. You can do the same if you want to pause this and then draw it, and then we'll find the missing sides and angles. Okay, welcome back. Here's the triangle that I've drawn. A is 7, B is 15, angle A is 26 degrees. I drew my angle A off to the left, and side B is 15, so that means angle B has to be over here. We don't know angle C, we don't know side C, but here's also angle A, or side A, side B. It does look like we have a side-side angle, 7, 15, 26, and that 7 is less than 15. Now we don't know for sure if it's going to be more than this height down to the base, but we're going to right now take it with the assumption that it is, so that this 7 is greater than H, but less than side B. Let me erase this so we don't get too many things filling up the screen here. Now let's find angle B. The sine of angle B over 15 has to equal the sine of 26 over 7. I'm going to multiply both sides by 15. And the sine of B equals, do the math here, it's 0.9394. Take the inverse sine of both sides. And B comes out to be 69.95 degrees. That's for the acute version of our triangle. Now we need to find the obtuse version, which is just supplementary. So angle B in the obtuse is equal to 180 minus 69.95, which is equal to 110.05 degrees. So there's our angle B for the obtuse triangle and the angle B for the acute triangle. So now you're going to draw these two triangles and find their missing sides and angles. So in this acute triangle, here's what we have. We have this angle as 26, this side is 15, 26 degrees, 7, and this angle over here is 69.95 degrees. Here's angle C and side C that we need to find. Here, we have 26 degrees, side 15, side 7, and then this angle in here happens to be 110.05 degrees. I need to find angle C and side C. Let's do this side first. Since I'm looking for this third angle, the measure of angle C has to equal 180 minus 26 minus 69.95. And so the measure of angle C equals 84.05 degrees. 84.05 degrees. Now find side C by using your law of sines. The sine of 26 degrees over 7 equals the sine of 84.05 over C. Get rid of fractions by multiplying by 7C. Over here the 7's cancel, over here the C's cancel, and we have C times the sine of 26 equaling 7 times the sine of 84.05, divide by the sine of 26, and C comes out to be 15.88 units long. Now do the same thing for the obtuse. Let's switch over to green for this one. The measure of angle C equals 180 minus 26 minus 110.05 degrees, and that comes out to be 43.95 degrees. That's this angle up here. So now using your law of sines to find side C, the sine of 26 over 7 has to equal the sine of 43.95 over C. I'm going to multiply to get rid of fractions, which means I'm going to multiply again by 7C. C's cancel over there, 7's cancel over here, and I have C times the sine of 26 equaling 7 times the sine of 43.95 divide by the sine of 26, and C comes out to be 11.08 units. And there you have the two triangles that are created by this ambiguous case, the law of sines. Please go to the next slide and you can try one on your own. For triangle ABC, B this time is 17, C is 24, and angle B is 16. What I'd like you to do is pause this, try drawing this triangle, then come back and compare it to mine. Then you can pause it and work it from there. Okay, welcome back. Here's the triangle that I drew. I always try to draw mine the same way. If I'm given angle B in the side opposite, I'm going to put angle B in the lower left-hand corner, and the side opposite is going to go in the upper right-hand side of the triangle. 24 is the other side, so we have this side-side angle, and 17 is less than 24, so this ambiguous case, again, is possible. If this is one triangle, then the other triangle is going to look something like this. Here's B, which is 16 degrees. This is 17 units. This is 24 units. Here is angle C. That's side A. And this is angle A. So now use your law of sines to find that first angle and then subtract that from 180 to give you this angle. Then find the other missing sides and angles. In other words, find angle A and side A. So go ahead, pause this, do that, and then come back and check your work. Okay, welcome back. Please go through, check your work, take a look at the answers, and I'll highlight them for you. Measure of angle A is 141, side A 38.73, angle C is 22.9, and that's for the smaller angle C. For the larger angle C, C comes out to be 157.1. Then A comes out to be 6.9 degrees. It's relatively small. And then side A comes out to be 7.41 units. Hopefully you enjoyed this lesson. Please take some time to visit with your teacher during office hours. Also, you'll have another lesson to practice these ambiguous case of signs tomorrow with Ms. Kochaver. So everybody enjoy the rest of your day, and I'll look forward to sharing some lessons on Chapter 8 with you next week or late next week. For those of you who are tuning into this very last slide, a little encore presentation. These math notes kind of summarize a lot of what we theorized about in a couple of those slides. If A is less than H, you're going to create no triangle. If A is equal to H, you create just one triangle. But you also create just one triangle if A is greater than B. In other words, if you have the big S, little s, A scenario. And when does the ambiguous case occur? That is the little s, big S angle scenario. And we also know that the sum of the two angles, so the measure of angle B plus the measure of angle B prime, has to equal 180 degrees. So then when you use your law of sines to find one of the angles, you're always going to be finding that acute angle. You're always going to be finding, in this picture, it's labeled as B prime. That's what your law of sines will find, LOC for law of sines. You'll have to find the other angle by subtracting the first angle from 180 degrees. So to find the measure of angle B, you're going to take 180 minus the measure of angle B prime. Everybody, have yourself a great day.